Hi friends, welcome to another episode of Decluttered. In today's episode, I want to show a telescopic series summation question. Now, telescopic series are very important from the perspective it becomes important for us as students to try and identify a certain pattern in the questions and then solve it. One of the best ways to solve for telescopic series is by splitting it into partial fractions. Without disclosing further, let me first present the problem to you. And like I always say, please do give it a fair shot and time. You may pause your video here, give it a fair shot and time. And once you have succeeded with the question or faltered somewhere, please come back to the solution and proceed. However, once you have looked at the solution, I would say please attempt it again to know whether you have successfully got the question or not. So, how the question goes is that we have a series given by summation n is equal to 1 to n, 1 by n plus 1, n plus 2. This can be written as p by q. We are expected to find what is q minus p. All on board so far? Excellent. I would want you to pause the video here. Please give it a shot and then come back to the solution. Whenever we see a number to have product in the denominator, the first thought that comes to my mind is splitting the number into its partial fractions. And by partial fractions, I simply mean writing this number in the form of why? Because when I take the LCM of the denominators, I will get nothing but the denominator of the RHS. The numerator of the RHS would be A into n plus 1, n plus 2, plus B into n plus 2, plus C into n plus 1 into n, which is equal to 1. All right. Now, when I open the brackets, I will equate term by term. I will say coefficient of n square is 0, coefficient of n is 0, and the coefficient of n power 0 or the constant term is 1. I will get three equations, and since I have three variables, I will be able to solve for them. Let me quickly write how it translates to. So I will get my equations would translate like this. A plus B plus C being the coefficients of n square, being the coefficients of n, and 2A equal to 1, since that is the only term that will generate the constant term. So A will be equal to half. Now substituting it in the other equations and quickly solving it, I will get B is equal to minus 1 and C is equal to half. So my given term 1 by n into n plus 1 into n plus 2 translates to, I will take the half common, into 1 by n minus 1 by n plus 1 plus 1 by n plus 2. That's 2. All right. Which I can again write it as 1 by n minus 1 by n plus 1 minus 1 by n plus 1 minus 1 by n plus 2. I have just split 2 by n plus 1 as 1 by n plus 1 and 1 by n plus 1 and clubbed one of them with n plus 2. All right. I will just rewrite everything. The term translates to 1 by 2 into 1 by n minus 1 by n plus 1 minus 1 by n plus 1 minus 1 by n plus 2. Now look at the magic. We have been given summation n equal to 1 to 9. Look at the magic as I substitute each and every value of n. 1 minus 1 by 2 minus 1 by 2 minus 1 by 3. This is with n is equal to 1. Now, I'm keeping that 2 outside. That's why I'm drawing the long curly bracket. Let me put n is 2. 1 by 2 minus 1 by 3 minus 1 by 3 minus 1 by 4. 1 by 3 minus 1 by 4 minus 1 by 4 minus 1 by 5. So on till 1 by 9 minus 1 by 10 minus 1 by 10 minus 1 by 11. So far, all good. And the magic happens right here where we see that this and this cancel, this and this cancel, this and this cancel. Like that, for these two set of terms, I'll be left with the first term and the last term. Similarly, here, this will cancel with this will cancel with this will cancel with this, so on. This will cancel. I'll be left with the first term and the last term, but with a minus sign. So what I am left with finally is half into 1 minus 1 by 10 minus 1 by 2 plus 1 by 11. Any doubts? No? All right. So this translates to half into which translates to a simple number that is 110 plus 10 is 120 minus 66, the whole divided by 2 and 110. 60 minus 33, which is 27 by 110. And Q minus P is 110 minus 27, which is 83. Because this is P, this is Q. All right. So, as you would have seen, telescopic fractions is a very important aspect of calculating certain summations. And it becomes important for us to identify such patterns in the question. Partial fractions is a chapter in itself that we learn in 11th state syllabus. It's a very interesting chapter. You may want to look at it out of your academic purpose, out of your love for maths, or whatever you want to term it, right? Great. If you love this video, please do like, share, and subscribe. Spread the word and spread our love for maths.